To discuss software architecture. Uh, we are going to start actually the introduction to software architecture. Now, what's a software architecture? Basically, we have to start with something called architectural design. Okay. Uh, Now, when we say architectural design, what is a architectural design? Architectural design is uh, basically about understanding of how a system should be organized. Okay, and obviously it is the designing of overall structure of that system. So it is a design process uh, that is to identify the subsystems that makes up a particular system and the framework for the subsystem control and communication. That is the way the components of that subsystem communicate with the other systems. Okay, so and the controlling of those subsystems. This is what the overall architectural design means. It is basically the architectural design. When we talk about architectural design, it is a critical link between the design and requirement engineering. Okay, the actual design and the requirement, it makes up a link actually between the actual design and the requirement engineering, because it identifies the main structural components in a system and relationship between them. Okay, so uh, it is and the output of architectural design process is the architectural model that describes how the system is organized. A system, how the system is organized as a set of communicating components. Okay, so when we initiate this process of architectural design, the output that we get out of this architectural design is nothing but an architectural model. And what is that architectural model? It is basically, it identifies the components and the communicating and a set of communications that component does. Okay, so that is what the architectural model is. So that comes as the output of the architectural design process. So we can call this the output as the as simply as the software architecture. Okay, or description of the software architecture, that is the architectural model. So this is what we have discussed about the architectural design in a previous slide. Uh, these are the points basically already I have mentioned in the previous slide itself. That is, an architectural design is nothing but actually a early stage of system design process. You can say initial stage of system design process, because it identifies the main components of the overall system. Okay, and the communications. So this architectural design basically makes a link between the specification and design process. I already told you, it makes a link between specification, mean the requirement engineering process, and the actual design process. Okay, so it makes a link between the specification and design process. So many a time this architectural design is carried out uh, in parallel with the specification activities. That is, it is carried out in parallel with the requirement activities. Okay, requirement engineering process, and it obviously identifies the identification of major components and their communications. That already I told you. So here is a example of a architecture of a packing robot, uh, packing robot control system. Okay, so it is basically uh, say we can call this actually the system architecture. Uh, just we can call the system architecture of the packing robot control system. Okay, so it has these main components like the vision system, that is the system, actually the vision component, you can say this one, vision component, or you can say vision system. Then the component that identifies the object, that is used to identify the objects, like object identification system, arm controller. Okay, then there is the another component which is the packaging selection system. Okay, so these are all different components which are interconnected. So the output of the overall design process, that is the architectural design process, that gives this architectural model as the output. Okay, and this shows the components and the links between them. So just to give an example about the architectural model, this output diagram is shown here. That is the different components of uh, the packing robot control system. That is the architectural design of the packing robot control system, and we get this architectural model. Now, this architectural model actually can be distinguished into two distinct categories. So, architecture in the small, one is architecture in the small, another is architecture in the large. Architecture in the small is basically concerned with the architecture of individual components. Okay, so that is at this level. Actually, it is concerned with the way the individual program is decomposed into components. So when we deal with the individual components, then it is the architecture in the small. Similarly, uh, when the system is too complex and very large, we call it the architecture in the large. So in the architecture in the large, basically may include other systems apart from the present system, the other system program components. Okay, so this architectural at the layers may distribute over a number of systems or number of computers. Okay, and that may those computers which are basically managed by different people or different companies. So this is the we can consider a small program architecture to be the architecture in the small, and the large and complex architecture to be the architecture in the large. Now, what are the advantages of having an explicit architectural model being created? That architectural design. Why do we need to carry out architectural design and to have the architectural models? So the main advantage, you can say, is to have, as you can see in the slide, that is the stakeholder communication, where the architecture may be used as the architectural model that can be used as a focus of discussion by different stakeholders. Okay. Uh, Similarly, the architectural model can be used for the system analysis. Okay, that is the architectural design decision actually have a profound effect on whether this architectural model meets the critical requirements, non-functional requirements. Okay, like performance, reliability, maintainability, etc. So, so these kind of critical requirements, like uh, non-functional requirements, is basically the architectural, from the analysis of the architectural model, we can find out whether the system is going to meet such non-functional requirement or not. Okay, so first is the stakeholder communication, that is different how the way the architectural model can be used by the stakeholders to communicate, okay, for high level discussions among them. Second is the analysis, the system analysis, through that is the actual system can be analyzed using the architectural model to, with a focus that whether the non-functional requirements will be possible with that particular system or not. Okay, similarly, with the we can have a architectural design being a common architectural design reusable for the systems which have common properties, or which are systems which are like similar systems. Okay, So basically system architecture is often the same for the system with similar requirements, and therefore the uh, these architectural models can have actually widely reused for those similar models. Okay. Mostly for architectural representation, simple and informal block diagrams are basically used to show the entities. Okay. Uh, but this kind of diagram with simple blocks to show the entities are mostly actually criticized because they lacks it said that they lack semantics, and actually it is criticized as the is not showing the actual relationship between the entities. Okay. So the simple architectural models are basically it is said that they are not very appropriate. Okay. So however, it basically depends. Use of such simple architecture basically depends on the use of the architectural model. So if for simple use, where you can show the architecture using in certain cases you can use the simple models with a box and the lines to show the simple architectural models also. For complex architecture, obviously you have to go into depth and use some different kind of semantics. Therefore, the box and line diagrams are the architectural diagram which are shown using the box and line diagrams are considered to be very abstract. Okay, so they are considered to be not showing the actually to not show the and actual relationship or the nature of component relationship, and nor they are actually showing the external visible properties of the subsystems. So this way they are considered to be inadequate, but they uh, they can be used to show some useful communication with the stakeholders and for project planning. So even though these box and line diagrams are simpler one, many a time they can be used as a very abstract way of showing the communication with communications, so that they can be used with the stakeholders and for project planning. Okay. So in such box and line diagram, the box basically each box in the diagram represents a component. Boxes within the boxes, if they are represented, indicates that the component uh, can be component that has been decomposed into some subsystems, subcomponents. Okay, and the arrow, the line that shows from the boxes to the other boxes, that actually uh, indicates that data. Okay, so arrow means the data and the control signals that are passed from some component to component in the direction of the arrow. Okay, so basically we can have some boxes as the components, and of course we can have subcomponents to be represented with the boxes within the boxes. So the use of architectural models are basically two-pronged. You can say there are two basic uses. One is to way of facilitating discussion about the system design. That is, the high-level architectural design can be easily used as a mode of discussion with the stakeholders. Okay, so different stakeholders can easily actually relate to such high-level architectural models, and they can provide different um, inputs on those architectural model as part, and which can be used for the requirement engineering and the design process. Okay, because the any stakeholders can easily relate to the overall architectural or high level architectural design architectural model, because those architectural models are mostly abstract. Those models does not contain doesn't have the details of the system. Okay, so it's an abstract model which can be understood by the stakeholders, so it can be used as a mode of discussion with the stakeholders. And also this architectural model, the overall architectural model, can be used as the mode of documenting the entire system. That is, because it actually produces the it shows the entire system, entirety of the systems, and different with the different components, interfaces, and the communication among them. So those entire system, the way entire system is going to behave, what kind of components the system is going to have, the kind of interfaces between those components, the communications among those components are all shown in the overall architectural design. So they can be easily used for documenting the entire system. Okay. So the architectural design is a creative process which can actually vary from the this particular process can vary from the type of system to be developed. That is from system to system development. So for some system, the architectural design can be of different kind. The process can be different kind. Where for the other systems, it can be slightly varying and have a different kind. Okay. So, but however, this actually contains some common decisions. Okay, which spans across all the design processes. Even though the architectural design can be different from one architecture to another architecture, but there some design decisions are uh, can be common for all those, irrespective of the architecture that is being created. Okay, so and these design decisions, of course, uh, actually controls or affects the non-functional characteristics of the system. Okay, so for making the design decisions, the architect have to answer certain questions. That is, based on their knowledge and experience, they must consider some fundamental questions about the system. And these fundamental questions are like, is there a generic application architecture that can be used for designing the system? If there is already available application architecture which can be used the for this for the present architecture that is going to be designed. So similarly, how will the system be distributed? Okay, the way the system will be distributed uh, among that among the computers, or the among the computers is actually maybe considered. Similarly, what architectural styles are appropriate? Is there a common architectural style that can be used? Which architectural style will be appropriate for the particular architecture? Because there are different architectural styles, like say um, pipe and filter, okay, client server, peer to peer, etc. Different architectural styles are there. So which will be appropriate for that? So what approach will be used to structure the system, to create the structure of the system? What approach can be used? Uh, how will the system be decomposed into modules? So the overall system that is shown in the architectural model, how they are going to be decomposed into different modules. So what control strategy should be used? Okay, control strategy for controlling the components should be used. So how will the architectural design be evaluated? So once architectural model is created, so how would that be evaluated? For their efficiency. So how should the architecture be documented? So the way how the architecture can be documented. So these are the uh, fundamental questions that every architect has to take into account while going for the design decisions. So architecture reuse is basically can be done for the architecture which reflects on the common domain. Okay, that is where there are domain concepts are same for different for the systems. We can have the similar architecture for them. Okay, or similarly for the a particular product line, a similar kind of architecture with small variations can be used. Okay, so when we have a products to be developed, then for similar uh, products with small variations, the same kind of architectures may be used. Okay, uh, architecture of a system, if a complex and large system is there, can be designed around one or more architectural pattern or style. Okay, so we have the entire system architecture actually can have a similar or same kind of patterns that may be used. Okay, and these are also called as style. We'll be discussing about these patterns and styles in the next after some time, after few slides. Okay, basically a similar kind of pattern means actually they capture the uh, same kind of architectures. That is the, you know, when we have a system which have uh, a particular pattern being followed. Okay, so we have the um, essence of the architecture is just basically same for those. You know, the pattern is the same. Same pattern means the same essence of the architecture or same similar kind of architecture is being followed here. So it is basically it's also a particular when we have a common pattern to be followed means it is a reusing. So you can a kind of reusing being used. Okay, so these are the ways the architecture reuse can be done. So because of the close relationship between the non-functional requirement uh, and the architectural models, so the kind of architectural style that will be used should depend on the kind of non-functional requirement the system is going to provide. Okay, that is the, the kind of non-functional requirement that is expected from the system. Okay, so depending on that, the architectural style will be chosen. So here we actually broadly classify the kind of architecture that needs to be used when for different kind of non-functional requirements. Suppose for performance, when the requirement type of non-functional requirement required from the system or expected from the system is performance, then we can have the components within a we can have large components within the same system. Okay, so that the communication is minimized. Communication between the components are minimized, and therefore we have a better performance. So in these cases, the large distributed fine-grained components are not used if the performance is the required non-functional requirement. Okay, instead of that, the bigger components or large components within the same system are to be used to have the minimal communications so that the performance is enhanced. Similarly, when we have a security to be satisfied as the non-functional requirement, then we can have some layered architecture. Okay, so that the innermost layer are highly secured. Okay, and those critical assets are basically stored in the innermost layers. Similarly, when we have the safety as to be satisfied, safety requirements to be satisfied as the non-functional requirement, uh, then the localized safety critical features in a small number of subsystems may be used. Okay. Similarly, when we require a high availability of the system, okay, when there is the non-functional requirement is the having is that the system should be highly available. In that case, some redundant components may be used. Okay, um, to make the system fault tolerant. Okay, so that the system becomes highly available, because so system should not fail, right? So it should be a fault tolerant system. So we must have a redundant components being used there in such cases. Similarly, when there is the maintainability of the system is the main non-functional requirement, then obviously we need to have some fine-grained components. That is, the components should be small, and means the replaceable components should be used. Okay, uh, to have the maintainability proper, because the large components the maintainability may be difficult. So when we have this components created in such a way that they are small and finely grained, then we can easily maintain the system. So in such cases, the architecture should have such components. Okay. So depending on different non-functional requirements, the kind of architectural styles can be chosen. Every architectural model basically represents some architectural view of the system. Okay. So architectural view or a view represents the system as composed of some type of elements, and relationship between them. Now, which elements are used in a view depends on what view you want to highlight. Okay, so depending on your intention, the view can vary. So different views basically exposes different properties and attributes. Okay, so it allows basically when it highlights different properties and attributes, it basically allows the stakeholders and analysts to properly evaluate those attributes for the system. So by focusing only on some aspects of the system, a view reduces the complexity, and therefore it becomes easy for stakeholders to understand the system better. So therefore view is something, what view actually the architectural model is highlighting, that depends on the uh, what communication the architect wants to make with the stakeholders. Okay, so you can the point here you can see is what views or perspectives uh, are useful while designing and documenting the system architecture. So that must be taken care of by the architect. Okay, and what notation should be used for describing the architectural models, that also is important while dealing with the view, because that is how the system will be analyzed and understood. So each of the architectural model basically represents one particular view of the system. Okay, so so actually it might show actually how the system in a particular view may show how the system is decomposed into module, or how the runtime processes interact with different ways. Okay, uh, when it is distributed across the network, all these actually. So for designing and documentation, normally we need to have the multiple views of the system. So we actually need multiple, you can say, different architectural model for designing the system. Okay, because all architectural model represents the different views of the system. Here we can see some of the common views, with the architectural model represents. Say the logical view, which shows the key abstraction in the system as objects and object classes. Okay. Similarly, we can have a process view, which represents the runtime view of the system, like uh, uh, that is the in the interacting processes. Okay, in the system. So that represents the runtime view. We can call it process view. Similarly, development view, which shows how the process is decomposed for development. That is how the software is decomposed for development. We can have the physical view, which shows the hardware allocation of the system. Okay, which processor is assigned which software component to be executed. Okay, apart from that, we can have the use cases and scenarios as another kind of view. So different architectural models which are being created may be based on different architectural patterns. Now, what is an architectural pattern here? Patterns are basically used for the representing, sharing, and reusing the knowledge, because they are already existing patterns which actually can be reproduced, okay, or you can say reused for already tried and tested methods. So architectural pattern is basically, you can say, is a stylish description of good design practices which has been already tried and tested in different environment. Okay, so uh, architectural pattern should also include the informations like, when they are useful, and when they are to be used in which kind of models, and when they are not useful for situation in which those patterns should not be used. So all these information should be there in the pattern, and patterns can be actually represented using tabular and graphical descriptions. Okay, so they may be represented using tabular and graphical descriptions. So first architectural pattern that we're going to discuss is the model, view, and controller pattern. That is called as the MVC pattern. Okay, in the MVC pattern, the model basically represents uh, it. Model component actually manages the system data and associated operations on that data. Okay, so those system data, when there is a data processing task, the system data is basically managed by the model component. Okay, and the operations actually that operates on the data. Similarly, the view component basically defines defines and manages how data is actually presented to the users. That is, the way it is presented on the screen to the users is basically given by the view component. And controller component manages the user interaction. The Because the users interact with the system through key presses, mouse click, etc. Uh, and this controller basically represents those user interactions and passes this interaction to the view and the model, because user basically wants to view the data in a particular format, and which is being managed in a particular way. So it basically comes from the controller component. Okay, because in user passes the information through controller component. So this is what the model, view, controller pattern is. Okay, now when this is used, it is used in a when you need to view the data or interact with the data in a multiple ways, then it is mostly used. This particular uh, pattern is mostly used. Okay, so the advantages of this particular pattern, MVC pattern, is that it allows the data to change independently of its representation. Okay, so basically it allows, or it makes the data change flexible. Okay, so that is what is the basic advantage of this particular model, artificial model. Sorry, artificial pattern. So also it supports the presentation of the same data in different ways with changes made in one representation shown in all of them. Okay, so this particular pattern also actually um, uh, allows the presentation of the same data in different ways. Okay, and changes made in one representation shown in all of them. So um, if any change is made in one representation data, it is basically available in all representation of the data. Okay, so that becomes an advantage. So similarly, there may be disadvantage, like it may have additional code or complexity. Okay, so all this that can be a disadvantage for it. So this is one example here of the model and view controller system. Okay, a pattern. Uh, this is the model view controller pattern. You can see here uh, the pattern has the model being specified here. That is the way the data is basically stored. So the way data is being managed, okay, is shown in the model here. Similarly, the view, the way it is presented to the users, okay, the controller, the way the users interact with the data, okay. So you can see with the way the users interact, there is a state change to the model, okay. It actually indicates that there should be a change of state in the model, and that is the change modification is viewed, is passed on to the view, so that the data is presented in a particular change way, the way it is being changed, okay. So this is how this particular pattern can be understood. So for web application architecture, the MVC pattern can be of this sort. That is, because it is viewed in the browser, while when it is a web application. So browser is basically interacting with the two components, that is the controller and the view, okay. Because every user basically passes the commands through keyboard or mouse and interacts with the browser, okay, to have a particular view of the data. Similarly, data is presented in a particular format through the browser. So browser is a common mode of communication between the controller and the view. So this is the MVC pattern for the web application. So in the layered architecture, there is another pattern which is called the layered architecture. Here we have a set of layers which provide services to be the components. Okay, the abstract components are considered to be the different layers. Okay, so there is explicit design of the interfaces of the subsystem when there is a layered architecture. So it basically allows incremental development of the subsystem of the different layers, and whenever there is a change in a particular layer, means only the adjacent layers are basically affected, okay. So in the layered approach, the change to make a change to a system has some advantages, because we don't have to change, it does not affect the entire architecture, okay. So uh, here is the general description of the layered pattern, that is the layered architecture pattern. So it's like, each related functionality is represented by different layers, okay, and the lowest level of the layer gives the basic functionality of the system. So and every layer provides some services to the layer above it, okay, so that the lowest level layer represents the core services that is likely to be used throughout the system, okay. So we can have an example system like, a layered model of a system with sharing copyright documents held in different libraries. So when such a layered system is used is uh, basically when building a new facility on top of the existing one, okay. If you have an existing system and if you are trying to build a new facility above that existing system, we can go for such architectural pattern like the layered approach, okay. So when the development is spread across several teams and each team is responsible for a layer of functionality, okay, then also we can go for the layered pattern. And also when there is a requirement for multi-level security, okay, if the system requirement is such that non-functional requirement is such that it must have a multi-level security, then we can go for the layered pattern, okay. So advantages of using this layered approach is like, it allows replacement of the entire layer as long as interface is maintained. So yeah, basically when the interface is maintained, it allows basically replacement of the entire layer, okay. Similarly, redundant facilities for authentication can be provided, because when there is a high level of authentication required for some system, then we can have this layered approaches basically advantageous. Okay, because the inner layer, the facility that is implemented in the inner layer gets authenticated in multiple layers. Similarly, the disadvantages, uh, there, there, there are some disadvantages with this pattern. That is, there may not be a very clean separation of the layers. Actually, it may be difficult to maintain a clean separation of the layers. Okay, and in many cases, the high level layer may have to interact directly with the lower level layers. Instead of going through uh, the intermediate layers, it may have to directly interact. Okay, so that in that case, the layered protocol, layered pattern rules are violated. So similarly, there can be performance issues in case of the layered pattern, because there can be problem because of the multiple level of interpretation of the service request as it is processed in at each layer. Okay, so performance issue may arise because in the layer patterns in certain cases. So this is the general description of the layered pattern. This is a generic layered architecture. As you can see, there are four generic layers that can be applied. That can have the layered pattern can have. The uppermost layer is the user interface, which is the abstract medium through which interacts with the users. So similarly, the second layer is user interface management and authentication uh, and authorization. So user management, user authentication is done via this layer. Similarly, the core business logic and application functionality is done uh, in this layer when the layered pattern is followed. And finally, the system support like OS and database is the downmost layer. Okay, the core layer, which is basically the uh, applied, the applied OS support and the database support. And here is an example of the system for sharing the copyright document held in different libraries. Okay, that the example that we in the description that we have given. This example, if you see the layered model for system for sharing the copyright document held in different libraries. So here we can have a web browser interface, for such kind of system that is for that particular system, which has followed the layered pattern. Similarly, the LIBSYS system login. This is the authentication level at the level 2, that is, and a form query management, printer management, etc. And a level 3, the actual business logic comes here. You know, uh, that is the document retrieval, write managers, accounting, distributed search. Okay, and lowest is the database support and the OS support. Another pattern is the repository architecture. In the repository architecture, when we need to have the data exchange between components or subcomponents in the architectural model, then this pattern may be used. This pattern may be beneficial to use. So uh, this may be done in two ways, where we can have a central database or the repository in a shared mode, which stores the database, and those data can be exchanged. Those data can be passed on to the subsystems. Okay, so or those data can be accessed by the subsystems, or where the subsystems maintain its own databases and passes data explicitly to the other subsystems. So when the data uh, sharing of data or passing of data becomes essential in the system, means when it is widely or the exchange of the data is widely used in the system, this particular repository architecture pattern is suitable one. Okay, so in this repository pattern, basically uh, data in a system is managed in a single place or single repository, which is accessible by all the system components. Okay, so in this particular kind of repository pattern, uh, the components do not directly communicate with one another. They communicate basically or interact through the repositories. Okay, so one example of the repository is the IDE or the integrated development environments, where the components use the repository of system design information. So when there are large repository of system design information, the component always interact, and I say for a system this one integrated development environment, the components they go for those uh, to interact with one another basically through those repository. Okay, so this is one example where this pattern may be used. Okay, if you have to design such an ID. So when to be used such a pattern, repository pattern, when when we have to have a system in which a large volume of informations are generated that has to be stored for a long time. So if we have to develop a system where the large volume of informations are generated and have to be stored for a long time, then this kind of system is repository pattern is useful. Okay, so basically uh, this kind of patterns may also be used in the data driven systems. Okay, where basically inclusion of data in the repository triggers an action. Okay, so those kind of data driven systems with this kind of repository patterns may be used. So advantages of this repository pattern is that the components can be independent. They do not need to know the existence of the other components. Okay, because they do not directly interact with one another. They interact via the repository, so they become independent. The changes made in one component can be propagated to all components. Okay, so through the repository, any changes that is made in one component may be propagated to the other component, all other components, and data is managed consistently because they are all stored in one place. That is also another advantage. Okay, because they are because repository is one, so it is stored in one place, so it's an advantage because to manage the consistency of the database. But this also makes a disadvantage. In disadvantage because there is a single point of failure, because if there is any failure in the database means the entire repository fails, whole system fails. So there may also be disadvantages of or inefficiencies in organizing all communication through the repository. Also, the distributing the repository across several computers may be difficult. Okay, so distributing the repository to all the connected components may be a difficult one. Here, the repository architecture being applied to the IDE as defined in the example in the description part. That is, when we use an IDE, develop an IDE to using the repository pattern, this can be a model, repository model. So you can see there is one repository, the project repository, common project repository, and these are the different components which are interacting with the common repository. They do not interact directly with one another. Each component, they are not interacting directly, but whatever interaction they are doing, they are basically doing through the project repository. Okay, so this is the architectural pattern being used for the IDE, one particular architectural model. There is another pattern which is the client server architecture. in this, where we have some servers providing services, and we have the clients which called on those services. We have a network which allows the client to access those servers. Okay, so basically it shows how the data and processing is distributed among the range of components. So this is a pattern which may be used in certain kind of uh, application, that is architectural models, which is called as the client server architecture pattern. Client server patterns are basically used in the systems which are actually organized into services, where the service delivery is the main concern. Okay, and in this kind of system, basically normally the services are provided by different servers. So clients are used to are the users of the services that access the servers to make use of them. Okay, so servers are the provider of the services, and the clients are the users of these services provided by the servers. So when we have to design such a system, or architectural model need to be created such a system, we need to use the client server pattern. An example of such a client server pattern is, suppose a film and the DVD library organized as client server system. So that can be one example of the client server system. So it is these kind of systems, the patterns are used when the data is a shared database which is to be accessed from a range of locations. Okay, because the servers can be replicated, and may also be used when the load on a system is variable. Okay, so when the client has to use the shared data and the services of the servers, then this kind of system can be used. Advantages: um, the servers can be distributed across network. So general functionality, some like printing services, etc., can be available to all clients and does not need to be implemented by all services, by all service. So when the services can be distributed across the network, and also when suppose the services needs to be available to all clients, in such situation, this kind of patterns can be advantageous. Similarly, disadvantage for such pattern, the client server pattern can be because the services are concentrated in one particular point. So there is a central point of failure problem, because if any failure occurs with the server, means that service will not be delivered. Okay, so sometimes performance may be unpredictable because it depends on the network as well as the system. Okay, there may also be management problem if servers are owned by different organizations. Okay, so these are some of the disadvantages that may arise from this pattern. The client server architecture for the film library or the DVD library, where you have the servers: catalog server, video server, picture server, web server. Okay, there is a common interface, internet, and different clients. You can see client 1, client 2, client 3, client 4. They are basically accessing these services through the interface. Okay, another architectural pattern used for data processing task is the pipe and filter architecture. Okay, so when we need to have the data processing as the sequence of functions that transforms the data that comes as the input to it and processes the output, produces the output, it can use the pipe and filter architecture pattern. Okay, So here is the description of the pipe and filter pattern, where data processing tasks are basically done by the components which are called as the filters, and these filters basically take data as the input and produces some data as the output. Now the data flows from one filter to another filter through a pipe. So these are connection lines are called as the pipes. Okay. The example of the pipe and filter pattern can be uh, suppose the processing of invoices can be an example for the pipe and filter pattern, where architectural pattern which may be used. Uh, it is used when we need to have a data processing application developed. Okay, it may be a batch processing or it may be a transaction based, where we need to process the data in separate stages to generate the related outputs. Okay, so in such kind of application, the pipe and filter pattern is used. Advantages are there, like it is easy to understand and support the transformation reuse. Okay, uh, so workflow like structure is used here, so which matches the structure of many business processes. So for development of application of many business processes, this pattern is commonly used, because uh, this pattern represents the workflow like structure. Okay, so evolution can also be done. Of the evolution is become easier to implement. It's straightforward by adding the transformations. Uh, so this can also be, it also has advantage, like it can be implemented for architectural model which has the sequential or concurrent systems. Okay, there are some disadvantages, like the format for data transformation has to be agreed upon between the communicating transformations. Okay, so format for what format of data transformation required should has to be an agreed upon one. So each for transformation must parse its input and unparse its output to that particular agreed format, right? The format which has been agreed up, form which is agreed upon. Uh, so this can also lead to the overhead, or it may mean that it is impossible to reuse functional transformation that use incompatible data structure. So uh, sometime it may lead to the incompatibility of the data structures. Okay. So this is the example of the pipe and filter architecture for the invoice processing. It's there. This is one filter, suppose, that is read issued invoices. It takes the invoices from the repository invoices and does the processing. These inputs comes to the filter and it does the processing, and the output goes through the pipe to another filter, which is the identify payments. Okay, it also takes inputs from the payment repository, its own personal repository, and then goes for the two two pipes are being passed. One goes to the filter issue receive, another goes to the filter find payment due. Okay, so the output out of the issue receipt is the final output which produces the receipts. Whereas the find payment due, if there is a due, then it goes to the find payment due filter, issue payment reminder. Here in this case, it issues a payment reminder. This is another filter, and finally, it produces the reminder as output. So this is the pipe and filter architecture for the invoice processing.